Okay, so today we're going to come on to forming and solving inequalities. So we'll do an example, then there's a your turn question and some questions I'd like to practice, and then come back and we'll go through some harder questions before you do the practice questions later on. So if we read through question 1 first of all, two sides of an isosceles triangle have length x centimetres, the third side is 3 centimetres shorter. The side length of a regular pentagon is x minus 4 centimetres. The perimeter of the pentagon is less than the perimeter of the triangle. And then we're asked to find the largest integer value of x. So the first thing that I'm going to do is calculate the perimeter of the triangle, which is going to be x plus x from the two sides which are the same length, and then the third side is 3 centimetres shorter than that, so that would be x minus 3. So in total the perimeter of the triangle is going to be 3x minus 3, and then the perimeter of the pentagon, because it's a regular pentagon, all of the side lengths are the same and they are x minus 4, so you've got 5 lots of x minus 4, which I could expand to get 5x minus 20, and both of those are in terms of centimetres. Now we're told the perimeter of the pentagon is less than the perimeter of the triangle, so 5x minus 20 is less than 3x minus 3. So now to get x's on both sides, I'm going to subtract 3x from both sides to get 2x minus 20 is less than negative 3. Now I'll add 20 to both sides, so I would get 2x is less than 17. And here I would divide by 2, so I've got that x is less than 17 over 2, which is also 8.5. So if x is less than 8.5 and I want to find the largest whole number that x could be, the largest whole number x could be must therefore be 8. And that would be my answer to that question there. So what I'd like you to do now is pause, have a go on the document at the your turn question, and then practice the test your understanding questions. Both of those solutions will also be on the document, so just check that you're happy with those and then come back and we'll run through example 2. Okay, so example 2, we have got that Tom, James and Johnny are applying to be head boy. 200 students are voting in total, and so far James has 35 votes, Johnny has 38 votes, and Tom has 45 votes. And we're asked how many more does Tom need to be certain he will win. So the first thing I'm going to do is just write in shorthand here what we've got so far. So James has 35, Johnny has 38, and Tom has got 45. And I'm also going to say let x be the number of votes that Tom receives after these initial values. And I'm going to say let y be the number of votes that Tom does not receive, so that either James or John receive. So Tom does not receive after the initial values. Now for Tom to win, Tom's total votes are going to be 45 plus x, and for him to win, that must be greater than both James and Johnny combined with the number of votes. So because Johnny has the next most number of votes after Tom, I'm going to take 38 as the value because that's the next biggest one. So Tom's 45 plus x must be bigger than 38 plus all of the other votes. So in a way, the worst case scenario for Tom is that all of the remaining votes go to Johnny and none go to James, and then Johnny will be his biggest competitor, and 45 plus x must therefore be greater than 38 plus y. Now I can also say that because there are 200 students that are voting, I know that the total number of votes, so all of these votes plus x plus y, must add up to 200. So 35 plus 38 plus 45 is equal to 118, which means that if 200 students in total are voting, there are 82 students left to vote. And these votes are either going to go to Tom or not to Tom. So I can say if there are 82 left to vote, then x plus y must be equal to 82. Now here, if I subtract x from both sides, I can say y is equal to 82 minus x. And then I can use that piece of information and substitute that into my inequality over here to be able to get an inequality just in terms of x. Okay, so I'm now going to substitute this in. So I've got 45 plus x is greater than 38 plus, and then instead of y, I'm going to write 82 minus x. And I can tidy that up by getting 45 plus x is greater than 120 minus x. Now I want to get the x's on both sides, so if I add x to both sides, I end up with 45 plus 2x is greater than 120. And then if I subtract 45 from both sides, I end up with 2x is greater than 75. And then if I divide both sides by 2, I end up with x is greater than 37.5. So if x is greater than 37.5, the least number of votes, the smallest possible value of x, must be 38, because you cannot have half a vote. So Tom needs 38 votes to be certain that he will win.